Hello everyone, welcome to my YouTube channel. Today we will discuss about buffer overflow attack. Basically, buffer overflow attack is one of the most common and dangerous security vulnerabilities in computer systems. A buffer is a temporary storage area in memory used to hold data while it is being processed. When a program writes more data into a buffer than it can handle, then extra data overflows into its memory locations. This condition is known as buffer overflow. Attackers exploit buffer overflow vulnerabilities to overwrite important memory areas, which can lead to system crashes, data corruption, or execution of malicious code. Basically, buffer is a block of memory allocated to store data such as user input, files, or network packets. Buffers have a fixed size, and programs must ensure that input data does not exceed this size. There is an example. We consider buffer for 10 bytes, and input provided is 20 bytes, and the result is overflow condition. And what is a buffer overflow attack? A buffer overflow attack occurs when an attacker deliberately sends more data than a buffer can handle, causing the program to overwrite nearby memory locations. This may allow the attacker to change program execution flow, inject malicious code, and gain unauthorized system access. How a buffer overflow attack works? The program allocates a fixed size buffer in memory. The program fails to validate input length. The attacker inputs data larger than the buffer. Excess data overwrites its in memory. Program behavior is altered or compromised. And normal buffer operation. Consider buffer ABCDFGHIJ with input ABCDFGHIJ, which is perfectly fit. And buffer overflow condition. Buffer ABCDFGHIJ and additional buffer KLMNOP. And final input is ABCDFGHIJ KLMNOP, which is an overflow condition. Types of buffer overflow attacks. First one is stack-based buffer overflow. In this type of overflow occurs in the stack memory. Attackers overwrite written addresses, allowing them to redirect program resolution. Here, stack-based buffer overflow. Given stack file, function documents, written addresses which are damaged by overflow, saved registers which are damaged by overflow, and construct buffer ABCDFGHIJKLMNOP with input ABCDFGHIJKLMNOP, which is an overflow condition. And finally, there are local variables. And second one is heap-based buffer overflow. This attack targets dynamically allocated memory in the heap. It may corrupt pointers to program structures. And diagram for heap-based buffer overflow. Here we consider heap, which is a row of blocks, and previous block buffer ABCDFGHIJKLMNOP, and damages next block KLMNOP, and final input ABCDFGHIJKLMNOP, which is an overflow slide condition. Impact of buffer overflow attacks. Buffer overflow attacks can cause serious security and system issues such as application crashes, data corruption, execution of malicious code, unauthorized system access, complex system compromise. A real-world example for a buffer overflow condition. One of the most famous buffer overflow vulnerabilities was the Morris bomb, which exploited buffer overflows lost to spread across system automatically. Prevention techniques. First one is input validation. In this, ensure all input data is checked before processing. And second one is bound seeking. In this, verify that data does not exceed buffer limits. And third one is stack and race. In this, special value is placed before written addresses to detect overrides. And fourth one is address-based layout randomization. In this, randomize memory addresses to prevent exploitation. And last one is secure programming practices. In this, we use safe functions, avoid unsafe memory handling, follow secure coding standards. And advantages of preventing buffer overflow: improved system security, reduced attack surface, stable and reliable applications. And finally, conclusion. Buffer overflow attacks remain a serious threat in computer security due to poor memory handling and lack of input validation. Understanding how these attacks work and implementing effective prevention techniques is essential for developing secure systems. By following secure coding practices and modern production mechanisms, buffer overflow vulnerabilities can be significantly reduced.